Right, it's 11:02, so maybe we have many people have been. I see people are still dropping in, so. Well, I think we should actually start. So anyway, so Katarina, could you put the first slides up, please?
Yes, 1 second.
Thanks. All right, great, thank you. So just to say welcome to all of you to this webinar, or what we're going to call it, with the about compute and storage resources for life science in Sweden. And as you know, we actually have quite a lot of different compute and storage resources in Sweden that are accessible for life science researchers. At the same time, the landscape in Sweden for infrastructure is a bit scattered, and it's not apparent easily how to access the different types of resources, or how to find the catalogs of where to find what's available. So now we are working on actually working out how to present that in a better way, to make sure that resources, there should be an easy way to access and to see what's actually available for life science research in Sweden when it comes to computer storage resources and who does what, essentially. So in this meeting here, we have a representative from Scilab Lab, from NICE, from NSC in Linköping that runs Berzelius. We have NBIS here providing bioinformatics support and resources, but also linking up with the UPMAX resources for sensitive data, for example. And so there's a lot of people here today who can present resources and services. And this will give you an overview of what's available. But of course, this is just the start of the work in a way, in how we can kind of jointly show in a clear way how you can access all these different things, and a little bit better who does what. So I'm not going to talk so much about that. There's going to be a number of presentations from each of the different providers here. And then afterwards, we're going to have time for questions and answers. So let's start with Liane from Scilab Lab.
Thank you very much. I'll just share my screen. Okay, so hopefully you all see my slides now from one street, if not. So as Johan mentioned, my name is Liane. I'm from Scilab Lab Data Center. I'm one of the project leaders there. So I'll be presenting two services today, both related to hosting and our compute storage resources. So the first will be Scilab Lab Serve, which can broadly be described as a service for hosting apps and machine learning models. And the other will be the Scilab Lab Data Platform, which can kind of be described as a service of two halves. So the first half is the technical hosting environment, and then the second half is a website to enable users to interact that can be described as a hub for data-driven life sciences in Sweden. So I'll go through the details of those. Just want to start off right from the beginning by saying that both of these are part of the Scilab Lab and Knut and Ella Stellenberg Foundation's Data-Driven Life Sciences Program, otherwise known in short for the DDLS program. So they are long-term sustainability. So there shouldn't be any concerns regarding sustainability when using these resources. So just start off right there, because I know that's a common question that a lot of people have. So beginning on Scilab Lab Serve, so you can access it directly with the, I think someone's not muted. Can we make sure everyone's muted? So I think so you can access right directly, and it's that serve.scilablab.se. As I mentioned, it's a service that hosts apps, so in particular, a single container apps. So these are your Shiny apps. So from our Shiny, you can get your Dash apps from Python and other single container apps, for example, Flask and Django. You can also have your trained machine learning models. So they should have a API or a graphical user interface to enable people to interact, but otherwise, all good. So we're still finalizing the exact resource limitations that we're going to have with Serve, but currently it stands at 10 GB CPU, 32 gigs of memory, 10 gigabytes of storage per app, so quite a considerable number of resources available to you there. And in the very near future, they will be offering GPUs as well. Another cool feature with Serve is that they have web-based JupyterLab and Shiny instances available. And these have been used to great success for teaching, for example, and it allows your students to have an environment that's already set up, so you don't have to waste or use that time at the beginning of your teaching sessions to make sure that everyone's in the right environment and that everyone has access to JupyterLab and Shiny. So it's been incredibly useful for teaching. So that's another element of this service. And now my slides won't progress. So basically, Serve Serve is free of charge to everyone associated with a Swedish research institution. And you can go and get yourselves an account right now today. So you will have access via your institution. You just need to go on there and use your LS logins to be able to get in. So that should be no problem. We understand that basically a lot of people work with international collaborators and that they would need access to this. This isn't a limitation with Serve at all, because we can gain your international collaborators access by having you request an account. All we need to know is that they are a collaborator of yours and should be given granted access to your projects. All of the applications and models that are hosted there, whilst I've talked about it being a service for Swedish researchers and available in Sweden, obviously, they are available, as you can see on your screens now, for Scilab Serve in the public app section. They're available worldwide, so it's not a restriction with regard to access of your app. They will be available for everybody. As you can see, the Scilab Serve has the beta logo on it, the beta tag. This should not be anything that puts you off from using Serve. It's been an incredibly stable service. It's basically there so we can continue to get feedback and make the service as best as possible for users. So it shouldn't be considered something that you are worried about when you consider using this service at all. Please get in touch with the team if you do need any support whilst using the Scilab Serve service, or indeed any service. So moving on to the Scilab Data Platform now. So what you see on your screens are a couple of shots from the web side of the platform. So I mentioned this was a service of two halves. So this is the web side that you're seeing. And right on the front page, you'll see the services. So these are the services that are hosted or linked via the platform. So you can get direct access to them. One of the services there is about hosting on the Scilab platform. So you can click on there and get all of this information that I'm about to give you, so you can read through it later. Please do go and access that, and feel free to get in touch with us via the web interface should you have any questions or queries. Also available as part of that service is the application form. So you can go there and know exactly what we need to tell you. So basically, you don't have to remember everything that I'm about to say to you now. We have a set of commitment to the provenance and the ownership rights for research individuals or communities or organizations in your institution. So we don't require that you provide us with any kind of credit associated with providing the hosting for your data-centric tools or databases that could be put on the platform. What we provide from the data center side or the data platform side is hosting provided free of charge for those affiliated with a Swedish research institution, 1 year at a time. This means that basically you'll hear from us at least once annually to kind of check that everything's running smoothly and you want to continue having your app for this tool or database hosted for another year. So everything's running smooth. That was what you will get in terms of contact, basically. This isn't a service for sensitive data. So it's only for data that is considered non-sensitive. Nothing should be hosted in a sensitive manner here. We are able to provide a URL in the form of name of your service. So that could be anything you want it to be, .data.scilablab.se. If you want to use your own URL, you are able to buy that and link it up. And if you already have a URL where it's hosted and want to kind of just move the hosting but continue using the URL, we can also link it in. That is no problem at all for showing on the platform. In terms of requirements, we require that it has a value to the wider research community. So basically, it cannot just be hosting that benefits just your research team or your research community. You have to be able to show that it provides a wider set of value. All the content, including the data, has to be held under an open source license. As with everything that's at our data center, we believe in making everything that's open and as fair as possible. There has to be an active maintenance of your tool and database, which basically just means that we require some contact information should any bugs, throw off, or security issues arise. Then we will need to be able to get in touch with you. The container images should be held openly and in line with open container initiative specifications. We would need some information about usage information just so that we know that we are giving you the resources that you need to be able for everything to be able to run smoothly. It cannot be run as root. We need it to be run as an arbitrary user, ideally, and there has to be regular security scans and upgrades in place. So this is part of the active maintenance, and it just means that basically you could set up a Trivy scan, for example, for your GitHub to make sure that security issues don't arise. If they do arise, we will have to take down that tool or database from the platform if it is not resolved. Whilst we cannot directly help you with the development of that, we can help you with advice, so we can't get involved in the technical development as such. Okay, so part of what Johan spoke about in his introduction was about where we can find all of this information. So I told you about the hosting information that you can get access to. Another element that's on the data platform that you can find on the website is our resources section. And here we've begun to compile information about compute and storage resources. So you can go through and click on there and see a lot of information about a lot of the compute and storage resources that are going to be presented today. And obviously, if anything's missing from there, please do feel free to get in touch and we will look to supplement that information further. So it's a living document, not static at all. So just to say a wide range of thank yous to the funders and most of all to all of you for your attention today. So thank you very much, and I'll pass to the next speaker.
Thank you very much. I'll take on after you. Thank you very much. So let's see if I can share my screen. That would be wonderful. Right. So, my name is Johan Röber. I'm here representing the NICE organization, the National Academic Infrastructure for Supercomputing in Sweden. We offer compute and storage services, and I'm going to outline which one we have and how you can get access to them. Most of you should be eligible for access through an application procedure. So what is NICE? NICE is the successor to what was previously called SNIC, the Swedish National Infrastructure for Computing. We have taken over the responsibility for all roles that SNIC previously had. And in particular, in this context, NICE grants compute storage resources via grants application procedure. I'll skip ahead. The available resources that we have to distribute to applicants are of two kinds. There are computing resources and storage resources. Storage resources, if I begin in that end, is typically center storage, which is attached to the specific center, the specific compute resource that you apply for. Those are not spread among all sites, but are separate for each resources. Then we have the SwiStore Dcache system. I'm not going to go into it, but it might be of interest to you. You can store bulk. It provides bulk storage, which is available via specific interfaces on any system connected to the internet. Then we have the computing resources. Among them, we have Alvis, Bianca, Dardel, Lumi, Rackham, and the Swedish Science Cloud, and Tetralit. I am going to focus on Tetralit, Lumi, Dardel, and Alvis, because you will get another presentation detailing the use of Bianca for sensitive data, the NICE Sense initiative, and Rackham as well, I'm pretty sure. So these resources are pretty large. These are classical cluster resources. We have Dardel at PDC in Stockholm. It has CPUs and AMD GPUs. Around 1,000 CPU nodes and 56 GPU nodes. Then we have the AI ML resource Alvis, which is in Gothenburg at Chalmers, the center C3SE, which has a range of NVIDIA GPU nodes, among them A100 GPUs and V100 GPUs, and lighter processing GPUs as well. Then we have an older resource called Tetralit here in Linköping at NSC. It's primarily a CPU resource, a very classical cluster. It has just shy of 2,000 nodes and something in the order of 170 T4 GPU equipped nodes out of those nodes. Then NICE also handles the applications and for Lumi, the large Euro HPC resource in Finland, wherein we have a certain part, certain national part of the system to handle. So who can apply for these resources? Well, you have to be active at organizations eligible for VR grants. You will have to be affiliated closely with them. You need to have typically you will need to have a position there, so you get your salary from that organization in some respect. That's who can apply for a project. You can be a member of a project as long as the project principal investigator admits you into it, and then you don't have to be a employee of a Swedish academic institution. PhD students and postdocs can apply, but typically for smaller resources. Small allocations is a term present here and there. If you need larger resources, you need to be faculty member typically. And here I wrote associate professor or equivalent. I mean, we don't discriminate against actual professors, so it should be actually up from associate professor or up. And those are eligible to apply for medium and large allocations. Getting access then is the process for the principal investigator. First of all, the principal investigator is whomever applies for resources. It might be a PhD student in some cases or higher up in the academic hierarchy. First step is to create an account in Super. I will get back to Super very shortly. Super is the Swedish user and project repository. It is a database and a web-based user interface for actually making your applications. How to apply then for a project in Super? Well, you need to create an account in Super, and then you need to apply for a project in which you specify the objectives for the project and the means to reach this, like listing software, etc. And you need to specify the resources that you want, how much compute time on that resource, and the storage space you think you need. And the time frame. You need to specify between dates when you expect the project to run. There's also something you need to specify whether it's a new or a continuation project. It matters a bit. I will get back to that. You also should specify project members. This can be done at any time during a project. And those project members also need a Super account. Project members then apply for specific hardware accounts on granted resources. which is a separate process. You're not done when you've done becoming a member of a project in Super. You will click a button in the Super interface requesting an account on the resource as well. Moving on then to Super. This is the web interface that greets you when you log into this URL. This is where you either log in or you register yourself as a new user of the Super. Out of interest is on this page is also the proposals rounds, which I thought we would drill into a bit. A proposal round is just a batch of applications of a certain kind which are processed by the National Allocations Committee, which makes the decision on granting or denying a project proposal. Let's then drill into this. Clicking the proposals rounds, we are greeted with this screen, wherein we have certain types of rounds, categories. We have compute rounds, we have storage rounds. Storage rounds is some projects need extra space other than is needed in the compute round. You can apply for storage space in your compute round as well, but you might need a storage project of for various reasons. We also have the Lumi rounds, the AI/ML rounds. The AI/ML rounds typically go to specific resources, like in Gothenburg, the AI/ML resource Alvis, or for that matter, Berzelius, which is not actually a nice resource, but you can apply for it via this interface anyway, because, well, we did not, that was a decision to not make a specific interface for application to Berzelius, because then you need to learn a separate interface for that, and that's not very helpful to most people. High importance for you is probably the nice sense, many of you at least. This is the sensitive data project, which you can apply for on Bianca, and the Science Cloud as well. If we have a look at the compute rounds, there are different types of compute rounds. You have local compute rounds. That might be here in Linköping. We have the local resource for the university, the Linköping University, called Sigma. That's one of those that you would apply for here, but there are other resources as well. Then we have the large, medium, and small compute allocations, which are handled differently. Having a look at the small compute round, here's what you are greeted with. This is basically just a listing of resources which have this, which you can apply for using this category, the small round. We have then Alvis, etc. And the limits are stated there for what a small grant actually constitutes on those resources. Clicking the grayed out box, we then move on to the interface where you actually create the proposals. Here we have two alternatives. We have either to create a proposal from scratch, or you can base it on an earlier proposal. The earlier proposal option is if you already have a template, so to speak, of your own, which you want to base your new proposal on. That's very, very common because most projects run year in, year out and are with minor changes. So that's a time saver for whomever has a running project, or basically an old project, so they don't need to create it from scratch. Should we create a new proposal? It might look something like this. In this case, you're greeted with a bunch of click interfaces where you click boxes where you choose to edit certain aspects of your project proposal. Like the top, in the top here, you have a bunch of bookkeeping data that you need to make sure is correct. You need to make sure that your principal investigator, your personal information is correct. And then you move on typically to the basic information, which is where you specify your project description, what kind of resources you request, etc. Duration. Continuation is just a Boolean to know whether or not this is a project that actually continues from some previous project. That matters in some cases. You might want to assign a co-investigator to the project. This co-investigator can administrate certain aspects of the project in super interface. Directory name, there are more options here, but I only show the first page. The directory name is where you store your bulk data on the resource you're requesting. And that is, otherwise you will get a default name which is based on the diary number of your project. And that's typically not something you want. You would like something more descriptive. And that you can choose. Whenever you're happy with the project proposal, you will just click submit. And then it will be considered next time the evaluators meet to discuss these and weigh them against other project proposals. That would be it for me. I will be available, and other people from NSC and NICE representatives will be available in a breakout room after this if you have more questions on this. Otherwise, I would recommend to just check out this, the different web pages linked in this presentation for more details on all of it. Thank you.
Great. Thank you, Johan. So then we continue with the presentation about the NSC resources. I don't know if Sumi or Chuan who is doing the presentation, or both of you.
Yeah, I'll do the presentation. So I'm now sharing my screen. Right. Can you see my screen now?
Yes.
Yes, we can.
Okay, great. Sorry. So my name is Xuan, and me and my colleague Sumi, we are both working as application experts at the National Supercomputer Center in Linköping University. So in this presentation, we are going to provide you with some general introductions of the HPC resources available to researchers on Basilius. And we will also talk about how to apply for these resources and how to get user support from us. So Basilius is the flagship AI and machine learning cluster at NSC, and it was donated by the Knut and Alice Wallenberry Foundation in 2020. And the first phase was installed with 60 GPU nodes in the spring of 2021, and we just had an expansion just before summer, with which give us 34 more nodes. So now we have a total of 94 nodes, including 60 thin nodes and 34 fat nodes. So each node here has 8 NVIDIA 800 GPUs and 128 CPU cores. So the thin node has 40 GB video RAM and 1 terabyte RAM and 15 terabytes node local disk storage. And the fat node has a doubled size of the RAM, VRAM, and the local storage compared with the thin nodes. And regarding the data storage, there are 6 AI 400X, and that is 1.5 petabytes shared between all the projects. So to access these resources, the users have two options. Either you can use SSH for the command line interactions, or you can use ThinLink for a remote desktop environment. So this is how it looks like when you log into Basilius. We on Basilius have received more than 400 project proposals since 2021, and currently there are around 120 projects running on Basilius. And these projects cover a very broad research area, for example, material science, natural language processing, life science, and so on. And the allocation of the resources is carried out by an allocation committee of 4 people. And the committee reviews the project proposals based on a few criteria. So first is the scientific significance of the project, and then the feasibility of the project. Finally, they will decide on the amount of resources requested by the project. And in addition, the committee will give priority when allocating resources to projects funded by the Knut and Alice Wallenberg Foundation. So if you want to run your research project on Basilius as a PI, you have to be affiliated with the Swedish Academic Institute, and you have to be at least a PhD student or higher level. Applications for projects on Basilius are made in the so-called super by the PI, and you just need to submit a research proposal, which includes a brief introduction of the project that you are going to run on Basilius and how you plan to use the requested resources. And we use the format GPU hour as the measurement for the compute resources on Basilius. So as you can see, for the small projects, you will have 720 GPU hours per month. That is 1 GPU running for 24 hours a day for 30 days. And we have an upper limit that you can have for the compute resources. That is 28,800 GPU hours per month. So that equals to 40 GPUs running 24 hours a day for 30 days. And by default, you will have 5,000 GB for the data storage, if not otherwise requested. So here, these are the Basilius support team. And so Philip, Jonas, and Henrik are working as the system experts. They take care of the cluster operations and the system admins. And Sumi and I are working as application experts, and we mainly take care of the machine learning and AI related user support. And Johan is also supporting Basilius, but only for part-time. And if you need help or if you have some feedback to us, you can reach out to us either by sending emails to this Basilius support email address, or you can submit a user support in Super. So finally, I listed some examples of the user support that we usually offer. So we help users to install software on Basilius if it is not pre-installed. And for AI and machine learning projects, the development environments are usually highly complex. So there are many options on Basilius for you to manage your development environment. For example, you can use Anaconda to manage your Python environment, or you can go with the cluster, you can go with the container solution. Using a container environment will allow you a highly portable workflow and reproducible results between different systems. And the user will be free to choose their own operating systems and softwares independently of the host environment. And about the modules, so external softwares can be made available on Basilius to users via the module system. users are also welcome to make their requests to install new modules so that we can customize the Basilis user environment to be more effective for your projects. And on Basilis, we are using Slurm as the resource manager. So that's basically the same as most of the HPC platforms. And users need to run their jobs with the resources requested in a specific format. So we help users with this if the user is a beginner with the Linux and Slurm. And we also help users to resolve, some general error messages they meet during their work on Basilis. And most of the time, those error messages, they can be related to Python stuff, PyTorch, TensorFlow, and so on. So that's the slides I have, and thank you for listening. Welcome to check out our webpage for more information, and thank you.
All right, thank you, Juan. So then the last presentation from us now will be from NBIS.
Yes, so in a moment, hopefully I'm sharing the correct screen. That looks reasonable, does it? There we go. My name is Marcus Lundberg. I work in Uppsala, 50% in NBIS, the bioinformatics platform, and 50% at UppMax. And what does that mean? It means the following, that most of you will already know that NBIS provides bioinformatics support in 2 different tracks and also software development services. But there's also a unit that provides support for life science users on nationally available computational resources, the ones provided by NICE. Those are at UppMax, which is the Uppsala University HPC Center with, well, mostly it's NICE-funded compute clusters and storage resources, which are, as Johan described, free to use for basically everyone here. There's a lot of overlap between these 2 organizations. The people who are providing the NICE service for support for computational resources are also UppMax people. So we have a good contact between the hardware side of things and all the way up to the user side of things, which we like. The support is provided free. It's best effort. At the end of these slides, you'll find out how to contact us. But it's just, if you contact UppMax support, you also contact NBIS, well, vice versa, basically. What we do is we build and maintain a very well-stocked software library at UppMax, and we have some progress on establishing the same software library and at different NICE centers. First, we're targeting Dardel at PDC because there's quite a bit of storage left over there that we think bioinformatics users can pour over into. To give the scale of how many softwares that we have, it's well over 1,000 modules. So it's taken years to install, so it's quite valuable because it means that all the users, and we have 2,000 or so that are active, all the users don't have to install the software for themselves over and over again, and this saves thousands of researchers' hours every year. We also provide user training on our environments, and we help out when there's user support requests that come in through UppMax support. We can also help confused people find the right resource for their project. We've directed people to Berzelius if that's been appropriate, or Alvis if that's interesting. But also, well, we know the environment, and we can help you find resources you need. So what resources does Uppmax actually have? We have a few clusters, mainly these two, Rackham and Bianca. Both offer a very similar environment, a graphical login to Linux cluster, also console login with SSH, just like the other nice systems. Rackham is for non-sensitive data, so that's things like fish and bacteria and plants and whatnot. We have two storage systems attached to that. One for home directories called the Domus, which has snapshots and things, which is nice if you make a little mistake. Kex is a project storage. It's huge, it's fast, it's also quite full. We don't have any GPUs on Rackham, which is a pity because that limits what you can do there. That's why we direct people elsewhere sometimes. Bianca is a sensitive data system, and anyone working with human data is welcome to also contact us and discuss, hey, is it sensitive? Is it not? And then we can provide some guidance there. We are almost ready to get the new storage system Cygnus into production, and that will provide another 3 petabytes more space, so project can continue to grow for a while. We also have not a small amount of GPU resources. Sometimes they're quite well used, and sometimes they're not. So it's worth applying and trying to use them, because I think it's a good opportunity, and the more users we have, the easier we have to motivate more investments in resources that enable GPU powered computations on clinical data. Lastly, I want to mention an offload storage resource that we call Lutra. It's user funded, but if you have a large amount of data and you don't have high performance on it, then you can pay for storage, and it's like the cheapest storage you can find in Sweden, 500 crowns per terabyte per year. But you have to buy it in increments of 50 terabytes, so it's only for sort of large needs. All this data is backed up. There's 30-day incremental backup, which does mean that we strongly recommend you keep the data at home, have a primary copy yourself, because we can't guarantee integrity 100%. What else have I not said? Oh yeah, Bianca. Usually there's a need for have data processing agreement. We have a pretty smooth process for getting those signed pretty quickly. It's still worth contacting us as soon as possible when you realize you may need to use Bianca, because sometimes it takes a few weeks if the legal departments don't agree, but this works out very, very nicely nowadays. One final word, I guess, about why, no, never mind. I'll move on because the time's running out. We have some other services also that are sort of synergies with the nice funded resources that we have. NGI, the National Genomics Infrastructure, they have a production and delivery platform in our computer hall, and Uppmax is open to similar collaborations. Sweden and a few other smaller databases, they with sensitive data, they provision their data on Bianca, so the data stays on Bianca and is safe there with strong technical security. And then the Sweden group themselves, they handle data access questions, and basically if they send us an email saying this group is approved to use, then we can expose the data to their project on Bianca in a safe way. Similarly, we have with Simpler, it's a registry a health registry infrastructure, and they have their own little round in Super and handle project administration stuff. And they have a very nice way to just feed chunks of data out to their client projects. Super convenient, very cool. We're doing the same thing for another group called Cope, but that's not quite ready yet. Also under development is a quite large storage system that we procured for DDLS. It's called Spirula. The use of that is sort of still under development, but we're quite excited about collaborations like this, because when we tie things together, everyone's life is easier and we get less mistakes. It's just lovely. Here's how to get access. Johan already described in detail how Super works. We have some more sort of life science, UPMAC specific instructions on the URL below. To get the support type function, then just contact UPMAC support. Also, you can visit the NBIS drop-ins. We always have at least a couple of staff there, and you can ask computer questions there. That's all I had for you today.
Great. Thanks, Marcus. So now we have some time to sum this up and to get some questions in, and I think Ola will want to, can just Ola, do you want to say something? The word is yours.
I was asked to summarize in a few minutes. In that sense, it's kind of hard to summarize. I think it's been a very good sort of walkthrough of all the resources available. I wanted to sort of say something general in that sense, that it's sort of what you and many others should really appreciate what great resources we have in Sweden, and it's sort of that we have such large compute capacity that is available free of charge, of course, subjected to scientific scrutiny. I think that is sort of something that we have gotten used to in Sweden, but something that we really should appreciate more. And it's sort of, in many other countries, we don't have these resources, and we cannot do this type of science that easily, that a PhD student can go on and request the resource and have it running in the afternoon. That is sort of, that can be a much more cumbersome process elsewhere. And I think we should also appreciate all the experts that make this happen. We've heard some of people here today, both the systems experts and application experts that sort of, they work really hard for this to run smoothly. And that's also sometimes a very unappreciated aspect. But it's sort of that we have that scientists actually have very straightforward access to these resources. That we've heard of various different types of resources, how to apply for them and how to get help. Both in terms of compute resources from NICE, we have to learn this now, the new acronym after the successor of the SNCC, and the substantial resources we have that are sort of that we really should take advantage of. There's a lot of training events. There's some Arnold linked to a new event here in the chat also for Berzelius. There are pages on Scilab Lab web where there are many courses on how to work with these systems. NICE also organize courses and get together both online and hands-on courses. So there are all opportunities for people to get to know how to use these systems. And I think that's sort of today we've seen also, but there were some examples also more on, for example, from Lian in the beginning about hosting services and such. So in that sense, I think we're covered a lot here today, and I think I leave with this, that there are a lot of resources available, and there's no excuse not, if you are in need of more compute and storage power, to actually reach out and take advantage of it. So I think that was my summary, and I think I will give the word back to Johan to lead the questions.
Great, thank you, Ola. Yeah, I agree. I thanks for all the talks, and again we can take some questions. We know that there's going to be plenty of questions around the whole this compute and storage resources. We'll only have time to take a few now, but as you now know, at least you've seen who to contact and a few of the channels to talk to. So please follow this up with questions more directly. Johan, you want to add in on here?
Thanks. So I just wanted to mention that the bar for getting a small-scale compute project is not very high. So don't hesitate or be intimidated in any way. Just apply. You are extremely likely to get it approved, unless you write some crazy stuff. Don't do that.
Apply first, ask questions later is the recommendation.
Good. Let's see. So we had a question here from Kartik. I think I saw Marcus just answered it. So did you want to comment on that, Marcus, that specific question from Kartik?
It's a common question. We have some courses about using Bianca, and we get into the legal aspects there more. I always recommend everyone to go talk to their dataskyddsombud, their data protection officer at their local university. They're the ones with the mandate to make decisions what is acceptable behavior and what isn't. Everyone interprets the law differently, and there's a lot of gray areas, and we can't make that decision for you. We can just guide you. Oftentimes you'll just get the response though, you're the scientist, you're supposed to be the expert. So it's worth learning a bit about the context, and then you can make these decisions.
Yes. One thing that I can probably add to that is what we've seen a lot is that there's a lot of confusion often between what are legal issues and what are information security issues. And if you ask information security about legal issues, they may have things to say, but you should get to the legal department in that case. Most often, I would assume you would actually want to talk with your security departments rather than the legal departments in many, many cases. Then we also had a question related from Joachim about Bianca and sensitive data. Are there also people-focused resources like courses, certification, so to help practicing this? I understand what you mean. To ensure that members of a team learn best practices when working with sensitive data. So I think that there's, for example, like there are NBIS courses around sensitive data handling, I believe, Marcus, right? We don't really have a lot of, from our side, seen a lot of courses. Do you know if there's anything specific about that?
On Monday, that is this coming Monday, we have a course on Bianca and how to use that.
Yeah.
And that's a recurring course. We've had a few other courses with that are more sort of on the PI level questions. We went to KI and did a course like that, but we don't do those as often. That's another point. I think everyone here is quite open to providing courses and training and seminars or workshops, what have you. If you have a need, especially if you have a group of people or in a bigger context, talk to us, and then we will happily come and teach you whatever we know.
I have a question from Indranil about the NBIS and UPMAX. How can I share some data in Bianca or Rackham with collaborators who is outside Sweden? And I assume that means how do you let external collaborators outside Sweden get access to your project account on Bianca and Rackham? If you just want to share data outside of those systems, there are many ways to do it. But how would you get access to it, Marcus?
There is nothing that prevents an international collaborator from getting an account in Super and then applying for membership in your project, and then you approve that membership, and then they will be able to log in to Bianca and look at the data there. That's what we recommend, and there's many people doing so.
Next question again from Kartik. If Docker is supported in UPMAX?
Docker isn't, because it requires super user access. You need to be root to run Docker. However, Singularity is available, and Singularity, you can take a Docker container and make it a Singularity image very easily in 90% of the cases. If there's an issue there, then you have to do something more complicated. But try Singularity first.
Johan, that's the case for Berzelius too, right?
Yes, so this is very common. I don't think Docker is available on any nice site because of those security concerns. I mean, it's an open security breach to have that on, quite simply.
Yeah. Question if there's an upper project time limit. And I guess that goes for both Upmax and for Berzelius.
The quick answer is yes. Projects are approved for 1 year at a time, and that is mainly, even though we understand that a PhD student will work for 4 or 5 years, we want an annual review of what's happening on the systems so we can adjust allocation levels and make sure everything is on the up and up.
On Berzelius, the time limit is 6 months. That's for partly because of historical reasons. We did not know what kind of workload to expect. That's up for review. Right now it's 6 months. It might continue to be so. It might be extended to 1 year. That's the likely scenario.
And I think also there's that relates to the super projects that are pure storage projects. I'm sure you can have storage projects that also are longer, right? But not really long-term storage in the classic. Marcus, you know this.
Indeed. So one thing to be clear about is that NICE doesn't have any long-term storage, any funding to provide long-term storage solutions. The mission from VR is quite clear. It's active data only. So we strongly encourage and help users move their old data away. And a lot of projects involve piling a huge pile of data and looking at also the old data over and over again. And we understand that. And as long as you motivate that that's what you're doing, then we won't complain at you very much. But we do also see users who are just lazy, not deleting stuff. And we can see that in the systems. And then we complain until you delete. So please be a good citizen and make space for everyone else.
So I can also add on top of that, because I know that many people have asked about this, about long-term storage and about what the DDLS program is doing here as well. And the Scilab Lab has done some investments in data sharing platforms and the service platforms that Liana was mentioning. And in those data sharing services, there are quite a lot of storage involved that can be used for long times, but that would be as a part of the data sharing or the hosting services. So through those type of access for users who commit to open science practices and who will make sure that data and results are provided openly, they will be set up in the next within shortly set up services that can be used for that sense, but then it's part of a data sharing service. So more about that on the data scilablab.se website. I think that we have more information out about that. All right, it's 12 o'clock. Any more? Final question. No long-term storage for sensitive data as these services are under. Yes, that's true. There are no long-term storage for sensitive data as far as we know. But as we say, with the data sharing, with the right, we will be able to work on things where you can use for that. So we can answer those kind of questions in more detail. We know that long-term storage it's one of the biggest issues around.
So
all right.
Correct me if I'm wrong, but formally that falls under the responsibility of the university, the host organizations, right, where you have produced the data.
Not exactly. Archiving does, but long-term storage linked to, for example, availability and sharing and stuff like that is not necessarily that. Archiving is something that has a legal responsibility, but long-term storage is a service. All right. Thank you, everyone. It's 1 minute past 12. I think this was good, and I'm happy so many attended. Thank you again, all of you.
Thank you. Bye.
Thank you.
Thank you.
Så Katarina,
Ja,